So hello namaskar to the all chemistry lovers and doctors and engineers of the near future. Me Vijay Kumar Soni will welcome to the chemistry Wala channel regarding to just chemistry of class 11, 12th needs and just IIT. In previous video we have discussed about the a lot of topic regarding to coordination chemistry. Today we will discuss about the stereoisomerism in coordination compound. So this is the stereoisomerism. This is the second part of the isomerism, stereoisomerism. In previous video, we have discussed about the structural isomerism. What is the meaning of stereo? Here, stereo means just 3D. You can say stereo means 3D. 3D means three dimension. Means you can say three dimension are possible in the space. So what we can say that its mean is spatial arrangement. Spatial arrangement. So what we can say that just two or more compounds having same molecular formula. This is the having same molecular formula but different arrangement of molecule in space. Means if the arrangement of molecule in space is different but molecular formula is same, then that is called as the stereoisomerism. So phenomenon called as stereoisomerism and compounds called as stereoisomers. This was about the meaning of stereoisomerism. If we'll go with the types of stereoisomerism, then along with the just organic chemistry, there are two types of the stereoisomerism. One of the is your just you can say geometrical isomerism and another optical. Similar to it, here will be two types of the stereoisomerism. Two types. Number one, you can say this is the geometrical isomerism, and another number two is your optical isomerism. First of all, we'll go with the just geometrical isomerism, and after that we'll discuss about the optical isomerism. So first of all, we will go with the just geometrical isomerism regarding to stereoisomerism. This is the first type as a geometrical isomerism. Geometrical isomerism. Meaning of geometrical isomerism. Isomerism means having same molecular formula. So here will be having same molecular formula but different geometries of molecule. Those are known as just geometrical isomers, and this phenomenon is called as geometrical isomerism. If we'll go with the properties, then no doubt, due to different geometry, just physical and chemical properties will also different. Physical and chemical properties will also different. If we'll go with the geometrical isomerism, then there are two isomers. Generally, two isomers. What are they? One of the cis isomer and another trans isomer. So this is the one of the cis isomer and another is your trans isomer. Trans isomer. In generally verbally we can say that if same group are in same direction then cis isomer, and when same group are in opposite direction then that is called as trans isomer. So this is the, you can say, same group in same direction, and this is the trans is same group in opposite direction. If we'll go with the just geometrical isomerism, then there are two types of the compound. First, we'll discuss compounds just having coordination number 4. First of all, we'll go with the compounds having coordination number 4. So geometrical isomerism with the compounds having the coordination number 4. If we'll go with the coordination number 4, then we have discussed in previous videos. For the coordination number 4, there will two types of the just geometries. One of these is your tetrahedral geometry, and another is your square planar. This is the square planar. If we'll go with the tetrahedral geometry, this is the tetrahedral geometry M. This is your L. This is your L. Tetrahedral. And in tetrahedral, all the positions are same with the angle of 109 degree 28 minutes. Means all the angles are same. So you will say all angles are same, and due to having same value of the bond angle, just angles, tetrahedral geometry doesn't undergo any kind of the just geometrical isomerism. So doesn't undergo geometrical isomerism because all the angles are same with the value of 109 degree 28 minutes. But if we go with the square planar geometry, this is the square planar, this is the M, we can say this is the L1, this is the L2, this is the L3, and this is the L4. There are two types of the bond angle. One of the just L1 M L2 angle L1 M L2 L2 M L3 angle L2 M L3 equals to L3 M L4 angle L3 M L4 angle L4 M L1 angle L4 M L1. All are the angle with the 90 degree. And if we'll go with the other end, angle L4 M L2, or you can say angle L2 M L4, angle L2 M L4, and angle L1 M L3, angle L1 M L3 is equals to 180 degree. When the same ligand are present, at the angle of 90 degree, then you will say that is called as cis form. I am repeating my statement. If same ligand are present at the angle of 90 degree, then that will be a cis form. And for 180 degree, it will as a ट्रांसफॉर्म. रिमेंबर वन थिंग, सेम लिगेंड के बीच में अगर 90 का एंगल है देन इट विल बी सिस फॉर्म एंड फॉर 180 इट विल बी एज अ ट्रांसफॉर्म. This is the question also in CBSE and RBC regarding to NCERT. Why tetrahedral geometry doesn't undergo any kind of the geometric isomerism? Then you will say the value of bond angle will be same as a 109 degree 28 minute, but in square planar geometry there will two types of the bond angle. That's why it undergo geometrical isomerism. Now we'll go with the possible formula regarding to square planar geometry. There are a lot of examples and a lot of, you can say, arrangement or geometries. What are they? Listen me carefully. This is the first formula. This is the possible formula. First formula is your M A2 B2, where A is equals to B monodentate ligand. A and B both are monodentate ligand. So square planar geometry, this is the M will be at the center of the geometry M. This is the A. These are the two types of the ligands as a and A with the angle of 90 degree. B with the angle of 90 degree. You can keep two same ligands like this, A and A over here also and B over here also. So this is called as cis form. If we'll go with the angle of 180 degree, if this A is over here and B is over here like this, then this is called as transform. Cis and transform. We'll go with the example. This is the PT NS3 whole 2 Cl2. Then the forming two geometries will be as follows. This is the square planar geometry. This is again your square planar geometry. This is your PT. This is your PT. This is NS3. NS3. Same again with the 90 degree. This is your Cl and Cl. Same and just again with the 90 degree. This is called as cis form. Cis form. And this is called as transform like this. NS3, NS3, Cl and Cl. This is the transform. If you will go with the cis form of PT NS3 whole 2 Cl2. This is called as cisplatin. Cisplatin. It's a very important question regarding to uses of coordination chemistry. Cis form of PTNSP whole 2 Cl2 is called as cisplatin and it is used as anti-tumor or anti-cancer drug. It's a very important use. Next formula we can take just like this, Ma2BC. When two ligands are same and two are different, like this. This is the PT and S3 whole 2. This is the Br and this is the Cl. Then what will be? This is the square. This is the another square. This is your PT, like this. This is your PT, like this. This is the NH3 and S3. This is Br and this is Cl. This is NH3, Br and Cl. Now you will say, so Br and Cl both are not same ligand, but we know very well both are negative ligand, negative monodentate ligand. That's why they are at the angle of 90 degree. Then it is called as cis form. And when they are at the angle of 180 degree, like this, this is the Cl and this is the NH3, then it is called as transform. Transform. So this was about the just having two formula, Ma2B2 and Ma2BC. Now the time to discuss about the third possible formula. What is that? That is too important. Similar to this second formula. This is your third possible formula. We can take M, A, B, C, D. When A is equals to B is equals to C equals to D, all of our monodentate ligands. All are monodentate ligands. If we'll go with the example, then as example we can take PT. This is your NS3. This is your PY. This is your BR. This is your Cl. This is the Cl. Then geometry or geometrical isomer will be as follows. You all know this topic is too important and it exists a lot of matter. That's why there are a lot of videos. So keep watching because it's a very important part. So PT we can keep over here. This is the PT. This is your PT again. This is the NS3 neutral ligand. PY pyridine is also neutral ligand. Both are at the angle of 90 degree. This is the bromido. This is the chlorido at the angle of 90 degree. Then this will be as a cis form. While if they are at the angle of 180 degree like this, PY, this is the BR and this is the Cl. Then this is called as transform. So this is the for MABCD. Now we'll go with the another important formula that is too important because of it exists bidentate ligand. So how it can be? Listen me carefully. This is the fourth formula. M A bond A whole 2, where A bond A is your bidentate ligand. If anybody is confused on how its coordination number is 4, so bidentate ligand के लिए total number को 2 से multiply करते हैं, so its coordination number will be 4. That's why it exists square planar geometry. Regarding to this, we can take example. This is your PT. This is your GLY whole 2. You know GLY is your glycinato. GLY is your glycinato ligand like this CS3CO, just NS2CS2. COO negative. It's a bidentate ligand with the -1 charge. Bidentate ligand, donor atom nitrogen and donor atom oxygen. It is formed by just one of the important amino acid that is called as glycine. ग्लाइसिन से पार्टिकुलर्स का फॉर्मेशन हुआ, ग्लाइसिनेटो का। ग्लाइसिन ने यहां से अपना H+ लूज कर दिया। इसके रिगार्डिंग में बात करना चाहूंगा, इट्स वन ऑफ द अमीनो एसिड which is not optically active. So you will say this is optically inactive amino acid. Optically inactive. Now the time to discuss about the geometry of this compound. This is your PT. You can see this is the square planar geometry. This is also square planar geometry. PT. This is the PT. Just donor atom NH2 CS2. This is COO NH2 CS2 CO, and this is the O. You can see both donor atom, same donor atom at the angle of 90 degree. So this is called as cis-form. And if you will go with the another, then this is the NH2 CS2 CO, and this is the O. This is the O CO CS2 NH2. You can see same donor atom at the angle of 180 degree. So this is called as transform. So dear student, this was regarding to just geometrical isomerism having the coordination number 4. In the next video, we'll go with the just geometrical isomerism in coordination number 6. Till then, shukriya, dhanyawad. But remember one thing, subscription, like and share बनता है, क्योंकि कारवा आप लोगों के बिना पॉसिबल नहीं है। थैंक यू।